Navigation properties are often non-nullable references. Carlos prefers to represent those correctly in the code so that the compiler can check that they've been initialized. To do that, he will first declare a public constructor that initializes navigation properties. Entity Framework won't be able to use this constructor, so he will also declare a private constructor that it can call. This strategy documents the requirements for his development team and for the compiler, while also allowing Entity Framework to use the database to enforce those constraints. The venue and act navigation properties are non-nullable, as they should be, because a show has to have both a venue and an act. The warning is telling us that these properties are not initialized to a non-null value when exiting the constructor. And so, thinks Carlos, let's go ahead and declare a constructor that initializes these to non-null values. This gets rid of the warning, and more importantly, it documents for the developers and for the compiler that these properties must be set in the constructor. Carlos makes the required change in all the places where the code is adding a new show. Now the code builds, but when he runs the unit tests, Entity Framework throws an exception. It says there's no suitable constructor for the entity type show. And so Carlos declares a private constructor that calls the public constructor. Here, he feels safe using the null forgiving operator in order to satisfy those non-nullable parameters. You see, he knows that Entity Framework has declared those foreign keys to be non-nullable. And so there's already a database constraint that prevents a null value from being loaded into this entity. And so, even though a show entity will be constructed with null navigation properties, he knows that they won't be null by the time they get to his code, as long as his code remembers to include those properties. This private default constructor satisfies Entity Framework. It can use that in order to materialize entities. But that private constructor is not available to his development team, who must instead ensure that they set those non-nullable references. There are still a few warnings remaining. The dbset properties in the db context are not initialized. Carlos explores 4 ways to solve this problem. First, he determines whether the null forgiving operator is appropriate in this scenario. Then, he experiments with initializing the dbset properties in the constructor. After that, he explores declaring dbsets as read-only expression-valued properties. And finally, he lets the calling code obtain a dbset without a property. This last option is the one that Carlos prefers, but it's up to you and your team to determine which of these is best for you. Carlos is down to 3 warnings, and they all have to do with the GloboTicket context constructor. The constructor exits before initializing the venue, act, or show dbset properties. Now, Carlos knows the Entity Framework will initialize these properties, but the compiler doesn't know that. And so the easiest thing to do would be to use the null forgiving operator in order to tell the compiler that we've got this. So that gets rid of all the warnings, and the unit tests still pass. And so the null forgiving operator is actually just fine in this scenario. But Carlos isn't satisfied yet, so he wants to explore a couple of more options. The second option that he wants to consider is to go ahead and initialize those properties himself inside of the constructor. He uses the set generic method in order to get a dbset of the appropriate type. That also gets rid of the warnings and passes the unit tests. But Carlos isn't happy with this solution because he has to repeat every one of the dbsets twice. And so he now wants to try a third option. Instead of declaring the dbsets as auto properties, he can declare them as read-only expression-valued properties. Effectively, this means that we're going to call the set function anytime we need a dbset. But Carlos is okay with this because he knows that the set function is designed to be used in this way. If the set function is called multiple times using the same generic parameter on the same db context instance, then it will return the same dbset instance. There's no reason for him to actually store that dbset in an auto property. The warnings are gone and the unit tests still pass, and so this is looking pretty good to Carlos. But he's thinking, maybe we can go one step further. The dbset properties are used whenever we need to set up a query. But the set function is public, so this code could call the set function directly. and that would eliminate the need for the dbset properties altogether. So the warnings are gone, and the tests still pass, but there's one caveat. Entity Framework uses those dbset properties in order to determine which entities need to be configured within this DB context. Without those properties, it needs to get the information from onModelCreating. Every entity that's explicitly added to the model builder will be part of the model. Since Carlos is using apply configurations from assembly, he's relying upon the fact that every entity has a configuration class. If a developer forgets to create a configuration class for an entity, then they will get a runtime exception when they try to access the DB set. For example, if they forgot to add the show configuration class, then the show entity would never have been added to the model builder. And then at runtime, Entity Framework would throw an invalid operation exception saying that the entity type was not found. Carlos is satisfied with this compromise, and so this is the solution that he prefers. Now that Carlos has eliminated the non-null initialization warnings, he elevates them to errors. He and his team are able to maintain that level of protection because they are following a few best practices. First, they declare optional entity columns as nullable. This signals Entity Framework to set up the schema so that those columns allow null. For all other columns, they provide intelligent defaults. Then, they initialize non-nullable navigation properties in a public constructor. This is the constructor that domain services will call, but Entity Framework can't use it, and so they provide a parameterless private constructor as well. Finally, they use the null forgiving operator only when something else is keeping them safe. For example, when you know that Entity Framework is initializing a DB set, or when a database constraint enforces a non-null foreign key. They never use a null forgiving operator when it's application code that provides the value. So maybe null pointers were a billion-dollar mistake, but by working with the latest language features, Carlos and his team are able to put a little bit of that $1 billion back in his company's pocket. Hello, and welcome back to Entity Framework Core 6 Best Practices. I'm Michael L. Perry. Entity Framework has always been about developer productivity. But unless you're careful, that increase in productivity can come at the cost of performance. Let's win some of that back by identifying and resolving performance issues. There are actually 3 kinds of performance to consider. The first, and often the most significant, is database performance. That is, how much time is the database spending on a query? The second, and only slightly less significant, is network performance. That's controlled by how much data is transmitted between the database and the application, as well as the number of round trips. And finally, there's runtime performance. This is all the time dedicated to maintaining the EF data structures. Change tracking is a good example of this kind of work. We can follow a few best practices to improve performance in all 3 of these areas. Being more intentional about our link statements helps us with database performance. Fetching only the results that we need will help with network performance. And taking advantage of new EF Core 6 features like compiled models, as well as old favorites like no tracking queries, will help with runtime performance. But before we put too much effort into any particular query, we need to know which ones to focus on. Don't make any changes until you measure. Let's see how to do that. Query tags were added to EF Core in version 2.2. They provide a convenient way to attach information to queries in the log stream. You call the tag with method on the iQueryable and pass in a string that will help you to recognize that query. This might be the name of the service method or the query class that contains this link statement. EF Core 6 adds a new method called tagWithCallSite. This method doesn't take a string. Instead, it captures the file name and line number of the link statement. This is a low-friction mechanism for gathering metrics to identify poor-performing queries. Now, the call site will drift as new versions are deployed, and you make changes to the code. So make sure that you can identify the specific version of the code that generated a log statement so you can tie it back to the query. Now, if you want to compare performance from one version to the next, consider putting in the extra effort to define your own consistent tags. But if you want actionable information with minimal effort, then it doesn't take much time to call tag with callsite. Now, there's one more thing that you can do to help with identifying issues with queries. And that is to log the parameter values as well as the SQL statements. This is only appropriate for development deployments. Never log potentially private information in production. And while you're at it, be sure to enable PII logging in development as well. Carlos has taken advantage of query tags to identify problem queries in production. Since he has parameter values and PII logging enabled in development, he's able to see exactly what's happening when he reproduces the issue. Carlos has identified a poor-performing query. He will use anonymous projections to improve it. These projections will fetch only the columns that are needed in the query results. And then, by employing nested queries, he will replace entity includes with targeted subselects. And finally, the query will transform the anonymous projections into the desired model in memory, allowing for the use of functions that cannot be implemented inside the database. Query logs have identified a troublesome query in production. Carlos has set up a local scenario in order to test it in development. This query gets a list of shows by date and location. He's getting reasonable-looking results based on some test data that he seeded the database with. And because he's using query tags, he can see the location of the source code as well as the SQL query. The query doesn't look all that bad, so he opens it up in SSMS to try it out. And now he can see the problem. It's pulling back all of the ticket sales for the matching shows. That means that even for this test data, he's getting back almost 3,000 rows. And with production sales volumes, that's going to be a lot more. So he follows the tag into the source code in order to find out what's causing the problem. Ah, here it is. The query is including all of the ticket sales. The reason it does that is so that we can later compute the seats available. The solution seems simple. We can compute the seats available inside the database and avoid returning all of those ticket sales back to the application. He needs to get rid of those null forwarding operators since they can't be used inside of an expression. And now he doesn't even need the includes. He's projecting directly into the show result. And now he's ready to give it a try. Uh-oh, it looks like he broke something. Let's see what happened. It looks like we're passing in a function in order to convert a GUID into an href, and we can't call that function inside of the selects expression. So Carlos needs greater control over what happens in the database versus in the application. He can't run the function inside the database, so he has to extract the show GUID. But he can't store that show GUID in the show result because it doesn't have a property for it. So he uses an anonymous type instead. And then, after executing the query, he performs the projection into the show result in memory. This allows him to choose what is performed in the database and what's performed in the application. And now he's ready to give it another try. This time, the query works, and he's able to see the number of seats available. Looking good so far. And this time, the new query features a subselect rather than a left join. And that's looking promising. And now we can see that this query only returns 82 rows. It doesn't bring back all of the ticket sales for each of these shows. Instead, it's able to do that work inside the database. And so Carlos was able to optimize this query by favoring anonymous projections. He first projected into an anonymous type using the operations that can be performed inside of the database. This returned no entities, and so he had no include statements. He then projected from the anonymous type into the desired type, bringing in the operations that had to be performed outside of the database. The end result is a much more efficient query.